Okay, we're going to continue on with our video series on microchip, and we're going to talk about operators. Okay, the first group of operators we will look at are those that are used in our arithmetic expressions. So most of these should look familiar to you. An arithmetic expression is one that contains one or more operands connected by arithmetic operators. And these operands may be variables, constants, or a function that returns a value. There are 9 in total that may be used in an arithmetic expression. And these are broken up into 2 categories. Binary operators, which has nothing to do with binary numbering system, but these binary operators require 2 operands, so one on either side of that operator. So for example, x plus y to add 2 numbers together. So x would be an operand, y would be an operand, and in between that operator would be the plus. Unary operators are operators that require just a single operand. So if you had negative x, for example, the negative would be your operator and the x would be your operand, and it would return the negative value of that operand. So we'll see these in detail over the next few slides. Okay, this is the list of all but 2 of the arithmetic operators. They include the standard operations we are used to performing in our daily lives, okay, such as addition, subtraction, multiplication, division. And they are also the unary operators plus and minus to return the operand or the negative value of the operand. So one that you may need a review on is the modulus operand. There are many applications for this operator, but its basic function is to return the remainder of an integer division operation. Okay, so for example here we have this modulus down here, 10 modulus 3. It goes in 3 times into 10, gives you a remainder of 1. Also note that an integer, when it's divided by another integer, always gives you an integer, and the decimal portion that should be there is cut out. Okay, so this is the summary up here that you should be focused on and understand all of these different mathematical operators or arithmetic operators. Okay, if both operands here we have are an integer type, the result will be an integer type, as I've already expressed and explained in the last slide. Both int and char are considered integer types, but just remember that char is an 8-bit integer. Float and double are considered floating point types. So the division operator is a bit different from the others in that it can function very differently depending on the data types of the operand. So I said, again, just repeating myself here, if you divide 2 integer types, the result will be an integer. If one or both of its operands, because it doesn't have to be both, but just if one is an operand is a floating point type, the result will be a floating point type. So it's almost like it's contagious to the rest of the expression there. Okay, and it's very important to remember this because you can easily lose the fractional part of the number if you aren't careful, as in this example here. 10 divided by 4 should be 2.5. Well, it doesn't take any of that 0.5. It just cuts it right off and gives you 2. Okay, the final 2 general arithmetic operators are the increment and decrement operator. Both are unary operators because we only require one operand. So they may be applied on either side of the operand. One is called postfix, so you can see that plus plus after the operand here, and then the prefix where it happens before. When the operator is postfixed, okay, as in this example on the left, this means that we use the value of x first when evaluating the expression, and then we increment it afterwards. Okay, so you can see here we've used the 5 as part of the expression, and we've added it to 5 here to get to 10, and then we've incremented it to 6 after we've used it. The prefixed example to the right means that we increment the value of x first, and then we use it in the expression. So it was 5, but we are going to increment it to 6 first, then add it to 5. So we get 2 different results. We get an 11 here instead of a 10, and 6 is still the resulting value of x because we incremented it by 1. I wouldn't be too concerned about the prefix example on the right. You may see that in an example somewhere, but we will be using this postfix example predominantly in our tutorials. The next group of operators we'll be looking at are the assignment operators. You're already familiar with the simple assignment operator, which is the equal sign, which simply assigns the value on its right to the variable on the left. The compound assignments are a bit different, so we'll look at these in a little moment here on the next slide. Okay, these are all assignment operators. Again, the simple assignment one should be familiar to you at the top. You're assigning the value of x, or assign x the value of y. So whatever is over here on this right is being assigned to this variable on the left. The other ones, the compound assignment operators, on the other hand, might cause confusion for some of you who are new to C, or maybe you need a bit of a review here. So the basic idea is that they are a shorthand notation for expressing assignments that involve the same variable on both sides of the equation. So if I look at this example here, x times equal to y is the same thing as x is equal to x times y. Likewise, if I looked at x plus equals to y, as x is equal to x plus y. Okay. These are called relational operators, and they're used to compare two values and tell you whether the comparison being made is true or false. So for example, in the second line in the table, we are testing to see whether x is less than or equal to y. If it's true, this expression will return a non-zero value, which is usually called a 1. We say that. And if the condition is false, then a value of 0 will be returned. So special attention should be paid to this double equals down here, okay, which this operator is always confused with, you guessed it, the assignment operator, which we saw in the last slide, which is the equal. So we'll see an example here to show you how that can mix you up sometimes. All right, so one of the biggest mistakes, as I've just said, that programmers make is when they mix this double equal sign to the assignment operator. It's really important to understand that they're two completely different operators. Equals is used to assign a value to a variable. This is to compare two values and to return a true or a false. So what do you think will happen to the code here that you've got in this example? I'd like you to pause the video and maybe think about your answer. Okay, back at it. So a very common mistake, as we've said here, this statement will always be what? It'll always be true because x is being assigned the value of 5. Now that 5 is a non-zero value. So rather than being compared to 5, which is probably what this programmer meant to do, was put a double equal 5, but they didn't do that. So an assignment used where a conditional expression is expected. Okay, so you're using assignment statements instead of a conditional expression, will always be evaluated as true unless, of course, that expression that you're assigning is a 0. If you fall into this trap, it can be really nasty to catch it since the compiler won't flag it as an error. And this is an example of what we call a logic error. So the only way that you'll know that it's there is if you block out, or if the if block there will always evaluate true, and even in false conditions. And you'll have to pick that up somehow in your debugging. So really what will happen here is this example, the string high will be printed in the output window because x is always going to be non-zero no matter what condition is presented there. Okay, on to logical operators. These are typically used in decision making with an if statement, which we'll see later, and they can be used to selectively execute code based on the outcome of the condition. In the first example, if both x and y are 1, okay, are non-zero values, then we get obviously a 1. So this is like an AND gate. 1 and a 1 produces a 1. Anything other than that produces a 0. Or we should know that if we have any 1s on either side, we're going to get a 1. But if both are 0, we're going to get the 0. Logical NOT is just an inverter, so we know that it's just the opposite of whatever x is. Shift operators are very useful operators, and they will move the bits in an operand left or right by the specified number of bits. So it's a very useful set of operators that we see not being used enough. So you can see here, you're going to shift these left by y bits, or shift right by y bits. So you can see this example here, x equals 5. Okay, and if we want to shift the x to the left by 2 bits, you can see how I've taken these 1, 0, 1, and it's shifted it starting here. It shifted it 2 bits over, so it's no longer 5, it's now 20. If both shift left and shift right, the bits that are shifted out are lost. And in fact, what shifts in there is zeros. When you are shifting right, if the type is unsigned, which most cases it is, then the left side is 0 filled. Otherwise, the sign is extended. And bits moved out on the right are also lost. Okay, so just for general purposes, try to remember that those bits get lost, and then it's just substituted with zeros in most cases. Okay, so here you can see an example. If you're dividing by a power of 2, it's actually a lot more efficient to use a right shift instead, okay, as this example points out here. Okay, this slide and the next two form a single table, and I have already created a summary sheet that you can use as a reference to this, which summarizes the order of precedence and the associativity. So you can see the color bands, which are gray and light blue, indicate different precedence groupings. So for example, what gets evaluated first. So for example, the first 4 entries in the table all share the same precedence. These 4 operators follow the rule left to right associativity, which is used as a tiebreaker when 2 or more of these appear in the same expression. So the next group of operators, starting with plus and ending with type, which all share the same or the next level of precedence. Okay, so they're all the same here. However, if there's a tie, the tiebreaker is right to left. Okay, and let's go on to the next slide. You can see more along the lines of what you're probably going to be using here. On this slide, you can see there are fewer operators grouped into each level of precedence. So here you can notice that multiplication, division, and modulus are actually all on the same level of precedence, and they are evaluated though from left to right when more than one occurs in a single expression. The next level of precedence includes plus and minus, which is subtract, okay? And then so these alternating color bands indicate separate levels of precedence. So you can see it goes down the line here. And then on to the last slide, okay, we have another big group of operators with the same precedence at the top here. And then the assignment operator and all the compound assignment operators as well. Okay, so this last slide here, if we take a look at the 2 operators that have the same precedence, okay, their associativity determines the order of evaluation. So you can see that this first one with x divided by y modulus z, okay, would effectively mean that because the division and the modulus are part of the same order of precedence, that we would evaluate it from left to right. So x divided by y would be evaluated first, and the result of that would be modulated or modulus with this z here. Now, the problem with this is that, rather than trying to rely on the order of precedence, use brackets. That's the lesson learned here. So don't get into the trick or the mistake of trying to find out and write your code in order of precedence. Use brackets. Okay, use that programming practice of brackets. Okay, so that concludes our introduction to some of the fundamental operators that you're going to be using in C.